Hi, my name is Peter Mage with BD Biosciences.
Hello, my name is Kamila Czechowska.
Hi, my name is Veronica Nash, and I'm here to introduce you to our video about instrument standardization and in flow cytometry and AI. If you're excited about this topic, please come to our workshop, Chatflow, at CYTO 2024.
Welcome innovators, scientists, and single-cell enthusiasts. Today we're going to explore the topic of instrument standardization from the perspective of artificial intelligence. AI has fantastic potential to provide and, at the same time, gain new insights from good quality single-cell data. Indeed, good AI requires good data, and lots of it. Let's dive in and think about how instrument standardization can help generate higher data quality for AI, and how AI can be used to support this process. Instrument standardization is the process of ensuring that cytometers provide consistent and interpretable data across experiments, both over time and between instruments. Why does this matter? At its heart, a cytometer works by translating invisible biomolecular information into a measurable signal, such as fluorescence. But this process depends on the specific hardware and performance of the instrument being used. Instrument standardization aims at ensuring that variability in cytometry data arises from meaningful biological sources, rather than from the instrument itself. A requirement for achieving reliable clinical results, standardization is now also essential for data in longitudinal studies, such as single-cell-based clinical trials. Today, instrument standardization involves a range of approaches, some of which haven't changed for decades. Most cytometer manufacturers provide some standardization through automated setup routines. Although these are often not transferable across cytometry platforms, individual users, labs, and facilities often implement their own standardization techniques using calibration particles, reference samples, or other manual approaches based on their assay needs. These techniques can be labor-intensive and difficult to translate across labs or datasets, limiting the potential of cytometry as a data source for the kinds of groundbreaking insights that AI can provide. Good AI requires good data. The old adage, garbage in, garbage out, applies now more than ever. This is true not only for cytometry data itself, but also for data annotation and key metadata such as sample type, patient status, and more. As cytometry moves into the ultra-high parameter space of panels looking at 50 or more markers, new techniques must be developed by manufacturers, cytometrists, and bioinformaticians to ensure that increasingly large cytometry datasets are usable and valuable for AI applications. We can imagine the power of AI to enable instrument standardization in order to help produce better data. Existing generative AI tools could provide a more natural interface for scientists to set up their instruments, understand system performance, and troubleshoot problems in plain language. AI-powered inference could help identify and correct for underlying sources of instrument variability in real time, dependent on hardware sensors and signal processing. Post-acquisition data transformations could align datasets based on known metadata such as panel design and cytometer type, making disparate datasets comparable for powerful deep learning analyses. Long-term, could AI-powered standardization help us make cytometry truly quantitative? Could it alleviate the burden on cytometrists to manually set up, annotate, curate, and correct their data to account for instrument variability? Ultimately, the combination of AI and data standardization could help democratize single-cell science by making cytometry data shareable, interpretable, and applicable regardless of where it came from. The future is bright, but we all have work to do to get there. And what are your thoughts here? How AI can help in instrument standardization? Join us at live discussion at Chatflow Workshop at CYTO 2024 in Edinburgh.